People, so in this video we are going to talk about finding the nth term, which is simply a rule or formula for a given sequence. Okay, we have this first type of sequence, which is the arithmetic, and it's also called linear, whereby as you go from term to term you are increasing or decreasing by the same amount. Alright, so how do we go about finding formula for an arithmetic or linear sequence? I have two methods to show you, and this is method 1, where xn is equal to an plus b. Xn is the nth term, any term in general, and a represents the common difference, the amount by which every time you move from term to term you move by that amount. That is the common difference. And b here is a constant number which you must find. Alright, let's see how we can find it. First, we can find the value of a, which is the common difference, by looking at the first terms of the sequence that are given. You see, from 45 to 42 we are going by minus 3. From 42 to 39 we minus 3 from 42 to get to 39, and from 39 we minus 3 to get to 36, and so forth. So this minus 3 is our common difference. Now we plug it in place of a, so our xn is negative 3n plus b. Now b has to be found, and to do that we have to find a value for n and xn, and n is the position of a term and xn is the value of the term. Now if we look at the first term, take note, it doesn't matter whether you pick the first term or the second term or the third term, everything will work out whether you pick any one of them, because they are all coming from the same sequence. Now for this case we pick the first term, which has a value of 45, where we plug into the xn place, the n term, and n equals 1 is the position of that term. It's the first term, and it's number 1 in the sequence. So we plug 1 in for n. This is the value, and this is the position of the first term, 1. And now we calculate and find b. So negative 3 times 1 is a negative 3. And to find b, we add 3 on both sides, so b is equals to 48. And then we plug b in, and we shall complete our n-term rule. So our n-term rule for this particular sequence, 45, 42, 39, 36, is xn equals negative 3n plus b, and b is positive 48. So here is our rule. Let's look at the second method. The other method is slightly the same, but it comes in this format. Tn, which is the n term, is the same as the xn. Tn is equals to a plus n minus 1 times d. So what is this a? This a is the first term in the sequence. Take note, it's the term value, not the position. And this d here, that's the common difference, which is the same as that common difference here. So we just find these two things, we plug it in this general formula, and we simplify it down, and we should end up with our n-term rule for our current sequence. So let's see. From 45 to 42, we have a minus 3. From 42 to 39, minus 3. So we are minusing 3 all the time. And that's our common difference. Our first term is a 45. So just plug it in place of a and d. Tn is equals to a, which is the first term, 45, plus n minus 1 times the common difference, negative 3. And since we have n minus 1 times 3, we can expand the bracket. So Tn is 45 plus negative 3 times n is negative 3n. And negative 1 times 3 is a positive 3. Then we collect like terms. 45 plus 3 is 48. And plus minus negative 3 is the same as minus 3n. So here's our rule. The n term is equals to 48 minus 3n, which is the same as method 1. Xn is equals to negative 3n plus 48. Notice that they are the same, just that this positive 48 is put in front in here, and this negative 3n is put at the back. Alright. Now here's an example 2 where I'm using method 1, but we are shortening the process by substituting 3 things at the same time instead of substituting a first and then finding b by substituting one value and its position, one term and its position. So we are shortening the process by substituting everything at the same time. So here it is. We have our sequence 7, 13, 19, 25. Our common difference is positive 6, since we are going plus 6 every time we get to a new term. And the position of the numbers, 7 is the first term, so n is 1. 13 is the second term, so n is 2, and so forth. Now we are using the first term to find the value of b, so we substitute the position as well as the value into the general formula for the nth term rule. So xn, the value of the term is 7. A is the common difference, which is 6. N is the position of the first term that we got. We substitute these 3 in at the same time so we can find b. Alright, so the first value is 7. Our common difference is 6. The place value or the position of the first term 7 is a 1. First term, so 6 times 1 plus b. That gives 7 is equals to 6 plus b, and of course we minus 6 on both sides. That gives us a b value of 1. So completing our rule, to complete our rule, we just substitute a and b value, leave n there. So xn is equals to 6 n plus 1, which is the b value. And here's another example again for the second method. The nth term is equals to a, which is the first term, plus n minus 1 times d, which is the common difference. Take note, for the second method, we are only substituting 2 things, the first term and the common difference. For the method 1, we are substituting 3 things. One term, its position, and the common difference. Now after you find the b value, you gotta complete your rule. For method 2, after you substitute the first value first term and the common difference. The rest is just expansion and simplifying and collecting like terms, and then you simplify straight to your n term rule. So here our first term is 7 plus n minus 1. We do nothing to n minus 1, leave it there, times the common difference is positive 6. And then we expand this bracket. 6 times n is 6n. 6 times negative 1 is negative 6. And we collect like terms. You can go 6n first and then negative 6 plus 7, or you can go 7 minus 6 is a 1 plus 6n. You can collect like terms. Either way, so long as you bring them along with their signs in front of them. So here's our rule. The n term is equals to 6n plus 1. That's enough for this video. Don't forget to like, subscribe, and see you in the next one.